Welcome to today's Explainer, the hidden language of real life, algebra's everyday applications. I am absolutely thrilled you're here because today we are tackling what might just be the ultimate universal math grievance. We are going to decode the hidden language of the real world. Now, if you've ever stared at a textbook filled with numbers and letters all mixed together and felt your blood pressure spike, believe me, you are not alone. But what if I told you that you're actually already a master at this hidden language and that you use it every single day without even realizing it?
When will I ever use this in real life? Look, go ahead and admit it. You've asked this, I've asked this. It is literally the battle cry of frustrated math students everywhere. With calculators and search engines right in our pockets, it's so tempting to think of algebra as just a bunch of tricky problems designed to keep us busy. But this exact question is going to be our starting point. We're going on a really fascinating journey from math anxiety to real-world mastery to see how this hidden framework actually runs your daily life. Let's dive right in with a relatable little story. Picture a teenager complaining to her mom about a find the value of X problem, asking that famous question, when am I actually going to use this? Well, her mom, instead of giving some boring textbook answer, poses a real-world scenario. She says, I have enough money to half evenly between you and your sister for 2 new outfits at $50 each. Instantly, the teenager is doing mental math at lightning speed. She just intrinsically knows the hidden value in her mom's purse is $100. But the mom doesn't stop there. She hits her with another one. You have $300 and you want to buy some shoes that are all $20 each. How many shoes can you buy? Boom. The teenager immediately fires back the answer, 15 pairs of shoes. And this brilliantly illustrates our first major breakthrough today. The moment money, shopping, or personal priorities are involved, we are suddenly highly motivated and highly capable of solving for X. The math isn't the problem, right? It's the context.
So let's look at a quick definition here. Algebra, arithmetic introducing the element of the unknown, and a variable, the placeholder symbol for that unknown. Okay, let's dive into this a bit more. At its core, algebra really is just basic arithmetic. It follows the exact same rules of addition, subtraction, multiplication, and division. It simply introduces that powerful new element of the unknown. We don't know a specific number yet, so we just pop a letter in its place, like an X or a Y. They're called variables simply because their values vary depending on the specific problem.
The mental switch from basic math to algebra is actually incredibly simple. In standard arithmetic, like 1 plus 2 equals ? The unknown is always the blank space at the very end of the problem. You don't know the answer until you do the math. An algebraic equation, like 1 plus 2 equals x, just swaps that blank space for a symbol and pulls it right into the middle of the sentence. It's essentially just a tool that gives us a structured way to manipulate the information we do have so we can effortlessly find the missing pieces we don't.
Everyday uses of algebra: budgeting finances, calculating gas usage, planning travel times, finding pharmacological doses. The truth is, we are solving for those unknown variables all the time. When you look at your fuel gauge and estimate how far you can drive, you're doing algebra. Projecting future expenses for your budget, that's algebra. Figuring out exactly what time you need to leave the house to catch a flight based on distance and traffic, algebra again. Even in pharmacology, finding the correct dose of a medication based on someone's specific weight is a crucial literal life-saving algebraic equation.
Have you ever adjusted a recipe for more guests? Think about it for a second. If your favorite recipe feeds 4, but you're hosting a dinner party for 10, you have to adjust all those ingredients so you don't completely ruin the dish. Finding that perfect, delicious ratio, that is purely algebraic logic. You are analyzing unknown variables and solving them mentally on the fly, probably without even realizing you're doing math. It's just second nature.
Scaling up. From everyday household chores to the massive algorithms powering global technology. We've seen how algebra works seamlessly in our personal routines, tweaking recipes or budgeting for new shoes. But these exact same principles are the absolute foundation for the macro-level world of advanced computer science, business, and tech. When you take these formulas and scale them up, they become the hidden machinery that runs the modern world.
Okay, let's slow down here, because this is where things get super fascinating. Every time you open Netflix, Spotify, or Amazon, you get these recommendations perfectly tailored just for you. How do they pull that off? Well, they use matrices. A matrix is just a way to organize numbers in rows and columns. Picture a scorecard. You've got 4 users reading 5 different movies from 1 to 5 stars. If they haven't seen a movie, it gets a 0. So if user 1 gave movie 1 4 stars, but gave movie 2 0 stars, meaning they haven't seen it, how does the algorithm guess what they'll rate movie 2 and decide if it belongs on their home screen?
Cosine similarity, measuring the angle between two users' taste vectors to find matches rather than looking at vector length. Now, what's really interesting about this is how elegant the trick is. Imagine mapping out user ratings on a graph as vectors, basically arrows pointing in different directions. The algorithm doesn't care about the length of the arrow, meaning it doesn't matter if you rate 50 movies a week and your friend only rates 5. It only cares about the angle between your tastes. The smaller the angle, the higher the similarity. It's essentially a highly advanced matchmaking game, strictly using geometry and algebra to map human preference.
So, Step 1. Find users with similar movie tastes. Step 2. Weight their ratings for movie 2. Step 3. Predict user 1 will rate it 4.04 stars. Walking through the logic here, the algorithm calculates a similarity score between user 1 and absolutely everyone else. To predict the rating for movie 2, it isolates the users who did watch it. Say user 2 gave it 3 stars and user 4 gave it 5 stars. The system takes those ratings, multiplies them by how similar their tastes are to user 1, and creates a weighted average. Crunching those numbers predicts user 1 will rate it around 4.04 stars. It's a high rating, so the system says, recommend this immediately. And they do this using matrices for millions of users, billions of times a day.
Now for some advanced applications. Matrices powering factory robotics, algebra tracking genetics and DNA chromosomes, calculus designing curved architecture. This math goes way beyond entertainment. That exact same logic telling Netflix what you want to watch is used in robotics, telling mechanical arms exactly how to orient themselves in 3D space. Biologists use basic algebra to track complex genetics and map chromosomes. And calculus, which is just built straight on top of algebra, is what architects use to figure out the load-bearing requirements for stunning, curved structures like massive stadium domes and suspension bridges.
Algebra is very useful for describing or modeling things in the real world. That quote really hits the nail on the head. Algebra acts as a universal translator. Whether you're graphing a linear equation to figure out the slope of a roof, perfectly designing the curve of a telescope lens with a quadratic equation, or just figuring out if you should take the bus or a rideshare based on traffic probability, math isn't just about passing a test. It is the underlying invisible code of reality itself.
What unknown variable will you solve for today? I want to leave you with that thought. The next time you adjust a recipe, balance your budget, or get a shockingly spot-on movie recommendation, remember that you are an active participant in this grand mathematical language. You are way better at this than you might think. Keep your eyes open and start spotting those hidden equations in your own life. Thank you so much for joining me for this explainer, and keep learning.